Autological words are words that describe themselves. Word is autological, because word is a word. Noun as well. Writable and pronounceable are both writable and
pronounceable.
New probably used to be autological. English is actually a special kind of autological word called an autoglossonym. That is, the name of a language in its own language. So French would not be an autoglossonym. You'd have to say
Français.
A famous autological word is pentasyllabic, which means having 5 syllables. And the word pentasyllabic has 5, well, you get it. Hey, I wonder what an autological video would look like. Like this? Or maybe this? Wait, I think this actually counts. Anyways, autological words are cool and all, but it gets old fast. So a while ago, my friend came up with this brilliant idea he calls cological words. Cological words are 2 words that describe each other. So for example, shorter and longer would be cological words, because shorter is longer than longer, which is shorter than shorter. Third and first would also be cological, but only in the context of this sentence. And here's the kicker, the words autological and pentasyllabic are cological. Chew on that for a second. So what comes after cological? It's not like we can just keep increasing the number of words. Trilogical words would be a group of 3 words that all describe each other. But when I explored this idea, I found if you actually try to make trilogical words, it quickly devolves into finding 3 synonyms. So you might want to introduce the additional restriction of having the word not describe itself. I ended up calling this concept borromeological words, named for the Borromean rings, the mathematical set of linked rings where somehow no pair within them are actually linked together. If that doesn't make any sense, maybe this topologically equivalent rendering helps illuminate things. Borromeological words, then, are a group of 3 words where each one defines the other 2, but not itself. Some examples of borromeological words are synonym, antonym, opposite, and here's a really crazy one, tetrasyllabic, esoteric, and cological. Think about it. We'll come back to this. Promise. In 1979, a professor named Douglas Hofstadter published a very peculiar book called Gödel, Escher, Bach, which later won the Pulitzer Prize for nonfiction. It's a famously difficult book, sitting at over 800 pages, one that many have on their shelves, but few have finished. It's also not really about Gödel, Escher, or Bach. Growing up, before reading it, I always thought it was about the relationship between math, visual art, and music. Because, well, the book's called Gödel, Escher, Bach. But it turns out the book isn't really about that at all. The math, art, and music are just examples to illustrate one idea, shadows from different angles cast by the same central object, as the author describes in words and depicts on the cover. What's this unifying central idea? He called it a strange loop.
It's a term that I invented. I sometimes regret having invented it, but that's okay.
Strange loops are an abstract term describing hierarchical systems, where, by moving in one direction, you somehow end up back where you started. If that sounds impossible, well, they're not called normal loops. For example, you probably recognize this painting by M.C. Escher. It's a paradoxical illustration, each hand describing the other. You trace the path of description and end up back where you started. Wait, are these cological hands? In GEB terms, both the hands and cological words are really just examples of a strange loop with 2 levels. And they're not the only ones. Imagine a camera pointed at a mirror. There's the chicken and the egg. Even DNA must encode how to make more DNA. Strange loops are everywhere, if you know where to look. Now we know what to do with trilogical words. Forget this mess. Let's just make it a strange loop, where the first word defines the second, which defines the third, which defines the first. And in theory, you could keep going. 4 words, 5, 50. In fact, someone has actually done this. Not with words, but with code. There's a concept in programming called a quine, a program that, when run, prints out its own source code. And before you ask, it's generally frowned upon to just write a script that reads its own file. You have to actually reconstruct every letter from scratch, while keeping in mind that every piece of code you add makes reconstructing it more difficult. It reminds me a lot of self-enumerating pangrams, the most famous of which was created by engineer Lee Sallows. It's a sentence that describes how many letters are in the sentence, including all the words that were used to describe how many letters are in the sentence. The term quine was coined by, you guessed it, Douglas Hofstadter, who named it after the philosopher Willard Van Orman Quine. The simplest quines are actually surprisingly short. They rely on tricks like string encoding, storing the rest of the code as a string, then printing it twice, or string formatting, where the same string acts as both the format template and the data being substituted into the template. But this is esoteric programmers we're talking about, so things escalated. Which brings us to what might be the most beautiful piece of code ever written, the quine relay. Built by Yusuke Endo, who goes by Mame on GitHub. What's the quine relay? According to Mame, a Ruby program that generates a Rust program, that generates a Scala program, that generates through 128 languages in total, that generates the original Ruby code again, which I guess makes it an octo-vision centological piece of code. I mean, how would you make this? Think about it. If you spot a bug 70 languages down the line, your only recourse is to go all the way back to the beginning and make changes to the original Ruby script. And to top it all off, the original script is shaped like an ouroboros, which means at the end of the line, the last script has to spit that ouroboros back out, byte for byte, every letter and every space reconstructed. One more thing, Mame's website is called the Mame Memo. He's apparently a major Ruby contributor and even runs an esoteric programming competition for Ruby. Wait, what's this in the description? Curious about what kind of programs win code like this. So it outputs, no, you have to copy the whole text from you don't know to the end? Wait, you don't know to the end? There's no way. How is that code? The fuck? You're listening to Canon per Tonos from Bach's Musical Offering, a famous collection he wrote in 1747 for Friedrich the Great, the King of Prussia. Listen carefully to what happens. Per Bach's instructions, the piece modulates up by a whole tone with each repetition, but he blends it together seamlessly, so it's hard to perceive the change. Then the key rises again, and again, and again, and again. Now it's noticeably different from the beginning, but not the step immediately prior. If you play it enough times, 6 in total, you've climbed 6 whole steps, 1 octave, and find yourself back exactly where you started. The piece has no ending. Bach didn't intend for one. It keeps rising forever, but going nowhere. You might have noticed Bach's canon is a strange loop of a different kind of the one we've been looking at before. We can't really call it autological, or cological, or even hexalogical, because it never literally describes itself in the same way that, say, a quine does. It just climbs a set of stairs that turns out to be a circle. I did actually look up if there was such a thing as a truly self-describing song. I came across this thread, One Note Samba. I can't actually play it for you though. Unless we buy the license? How much does it cost?
This is just a little samba built upon a single note.
One Note Samba describes itself, sort of. It tells you about its structure, but not the complete picture. In 1931, Kurt Gödel built a statement that does describe itself completely. The result is called the incompleteness theorem.
The unavoidable consequence of few. There's so many people who can talk and talk and talk and just say.
So normally, math statements are about numbers. 2 plus 2 equals 4 is a statement that tells us something about 2s and 4s, using plus and equals to help. But in 1931, Kurt Gödel found a way to turn statements into numbers. The idea was actually pretty simple. For every fundamental operation like plus or equals, the building blocks of mathematical statements, just assign each of these its own unique number, like an ID. That's what's called a Gödel number. You can also combine multiple operations, whole statements, into their own new Gödel number. And that's it. Mathematics can now be written entirely as numbers about numbers. Okay, cool, but why go through the trouble? To destroy math. Gödel discovered that within this system, it's possible to build a statement that says, essentially, the statement with the Gödel number g can't be proven, but the Gödel number of that statement is g. So the sentence is pointing at itself. It says, I can't be proven, and that's the trap. If the system can prove it, then the statement's false, and the system just proved something untrue. If the system can't prove it, then it's true, which is fine, except now we have a true mathematical statement that we can never prove. This argument shows math to be incomplete at its core. But wait, there was a statement about a number, but the number represented that statement. You trace the path of description and end up back where you started. Sound familiar? This is totally an autological number. Gödel didn't just find a strange loop at the bottom of mathematics. He proved you can't build a system rich enough to do arithmetic without one showing up. This is exactly where Hofstadter wants to take us. Self-reference isn't a flaw you can design out. It's an inevitable consequence of complexity, which raises a question. If self-reference is unavoidable in any system complex enough, what's the most complex system you can think of?
As a youngster or a teenager, I was always interested in what it is that gives us a self or a soul or a consciousness or an I. And that was what led to my writing regression.
Think about what your brain actually does all day. It keeps a description of the world so that it can predict things. Where your keys are, what your boss will say if you're late, what moving your hand around will feel like. But of all the elements that make up this description of the world, there's one that shows up in every prediction, every plan, every memory. You. So why does Hofstadter say that you are a strange loop? Well, you have a sense of self, right? You carry a description of you. But you already knew that. So shouldn't that description of you technically contain another description of you? You not only have a sense of self, but are likely aware of that sense of self. We've seen this shape before. A statement about a number, where the number turns out to be the statement. The system didn't want self-reference. Mathematicians tried to keep it out. But make a system rich enough, and the loop shows up anyway. Hofstadter writes, the I is not a tangible thing, but a pattern. The brain isn't born with a description of itself, or what a person is. The self emerges gradually, as experience shapes the brain's abstractions, which Hofstadter calls symbols, into a system complex enough to be able to represent itself. Expanded on in his second book, I Am a Strange Loop, Hofstadter speaks of a complex web of symbols, concepts or ideas that interact and combine into compound symbols, which combine into more compound symbols, and so on. This is a drawing he made of his own symbol web, greatly simplified. Hofstadter argues the most central and complex symbol in the brain is the one that represents yourself. The self is a symbol, but it's a very particular kind of symbol, one that represents the system it's part of. It is something that describes itself. This ability to perform self-representation, to create a strange loop of description, is where Douglas Hofstadter argues consciousness stems from, the whole crux of the book. That once a system becomes complex enough to represent itself, it can't avoid creating something that feels like consciousness. So our brains are able to build a model of themselves. In doing so, the model becomes part of ourselves, which is the system that they're modeling. Your highest order symbol, how you define yourself, shapes how you experience and interpret the world, which in turn reshapes your symbols and representations, which then reshape how you define yourself, and so on. We've been speaking a lot about definitions, but how do we define definition? One of my favorite YouTubers, Toadpond, once compared the definition of art to the definition of definition. A definition is a tool that we use to express ourselves. Sometimes the definition is for other people, and sometimes it's just for you. The definition that you use tells us something about you. Personally, I like to use definitions very loosely. Tracing the path of description has led us to the question, how do you define yourself? I think there's something beautiful in the idea of us having the same structure as mutually descriptive words, Escher's art, Bach's musical offering, and Gödel's famous theorem. Of course, that's just Hofstadter's definition. Maybe you buy the framework, but not that last leap to consciousness. You're not alone. The philosopher John Searle hated the idea that minds are just patterns, because then, he argued, you could build one out of anything. Like, say, an innumerable number of empty beer cans strung up, clanking around in just the right way. Of course, that setup could never be conscious, even if it did model the strange loop of our minds. Hofstadter's response? Why not? Why wouldn't the beer cans be conscious if they were really replicating the same pattern? It's not the substance that counts, neurons or beer cans. It's the structure. If you still don't buy it, I can't blame you. But what's undeniable is that your definition of you says a lot about you. In other words, you are autological. Wait, how do we define autological again? Autological words are words that describe themselves. Sorry, I couldn't resist.